Dear learners, I welcome you all to this online teaching session. Today, we will discuss about practical 3, that is estimation of paracetamol and mefenamic acid using absorption ratio method. So, aim to estimate percentage weight by weight of paracetamol and mefenamic acid in given tablets using absorption ratio method, that is Q method, by UV spectrophotometry. The requirements: reagents and chemicals. You require standard paracetamol powder, standard mefenamic acid, tablets, that is your sample containing paracetamol and mefenamic acid, zero point 0.1 normal sodium hydroxide. This is the solvent to prepare standard solution as well as sample solution, and distilled water to prepare zero point 0.1 normal sodium hydroxide solution. Apparatus: you require volumetric flask 50 ml, 100 ml depending upon your requirement, 10 ml volumetric flask, pipettes, beaker, funnel. You require Wattman filter paper for filtration of samples and tissue paper for wiping the outer surface of your cuvette. Instrument equipment: UV visible spectrophotometer and high precision weighing balance for weighing purpose. Again, the drug profile for paracetamol and mefenamic acid. Coming to preparation of standard solutions for mefenamic acid and paracetamol. So for paracetamol standard solution, you have to weigh 5 milligram of standard paracetamol. You have to transfer into 50 ml volumetric flask, make up the volume up to 0.1 normal NaOH, dissolve it properly, sonicate the solution and filter it. It will give you 100 ppm solution. From this you prepare 10 ppm solution by diluting 1 ml of this solution into 10 ml. So you will get 10 ppm paracetamol solution. Coming to mefenamic acid solution, standard solution. Similarly, 5 milligram of mefenamic acid weigh, transfer it into 50 ml volumetric flask. Add small volume of 0.1 normal NaOH, dissolve, sonicate it and make up the volume up to the mark with NaOH and sonicate it and filter the solution to get 100 ppm of mefenamic acid solution. From this you have to prepare 10 ppm solution, so you have to do 10 times dilution. So 1 ml of above solution diluted to 10 ml with 0.1 normal NaOH will produce 10 ppm of mefenamic acid solution. Now coming to our tablets, that is our sample. The sample is having paracetamol, both paracetamol and mefenamic acid as a APIs. You have to take average weight of these tablets. For 20 tablets you have to individually weigh 20 tablets and find out average weight. So the average weight of these tablets is 930 milligram and the label claims are mefenamic acid 500 milligram and paracetamol 325 milligram. That means one tablet having average weight 930 milligram contains 500 milligram of mefenamic acid and 325 milligram of paracetamol. How will you prepare sample solution? So as we know that our tablet average weight is 930 milligram. So you have to crush the tablets and you have to make fine powder. So 930 milligram of tablet powder is contains 500 milligram of mefenamic acid. Means in other words 500 milligram mefenamic acid is present in 930 milligram of tablet powder. So 10 milligram mefenamic acid is present in how much tablet powder? So X will be 10 into 930 upon 500. So it comes to 18.6 milligram of tablet powder. So 18.6 milligram tablet powder you have to weigh and you have to dissolve in 100 ml NaOH solution. Sonication is required and so it will give you 100 ppm of mefenamic acid. And you have to filter the solution and again you have to do 10 times dilution 1 ml to 10 ml. So the solution will contain 10 ppm of mefenamic acid into that. Now, this tablet powder not only contains mefenamic acid but also paracetamol. So, you should know that when you are transferring 8.6 milligram of tablet powder and dissolving it into 100 ml NaOH and further 10 times dilution was done, what was the status of paracetamol? So, we will see 930 milligram of tablet powder contains 325 milligram of paracetamol. This 325 is a label claim and this is our average weight. So 18.6 milligram tablet powder contains y milligram of paracetamol. So y is equal to 325 into 18.6 upon 930, that comes to 6.5 milligram of paracetamol. So when we were weighing 18.6 milligram of tablet powder, it was containing 10 milligram of mefenamic acid as well as 6.5 milligram of paracetamol, and that we dissolved in 100 ml NaOH. So 6.5 milligram paracetamol dissolved in 100 ml, so that comes around 65 microgram per ml, that is 65 ppm paracetamol. Again the dilution was done 10 times, so 6.5 ppm of paracetamol will be there into your final solution. So you have three solutions: standard mefenamic acid solution 10 ppm, standard paracetamol solution 10 ppm, and sample solution, that is your powder tablet solution, which contains mefenamic acid 10 ppm and paracetamol 6.5 ppm. So how will you proceed? First you have to take lambda max. You have to scan both the solutions. You have to scan both the solutions and you have to generate overlay. So when you scan mefenamic acid from 200 to 400 nanometer, standard mefenamic acid solution, and the secondly go for paracetamol 10 ppm solution and generate the overlay, because we want isoabsorptive point or isobastic point. So you will get isoabsorptive point, and that you have to, the point where the absorbance of both the components is same, maximum absorbance of both the components is meeting each other. So that will be our lambda 1. So isoabsorptive point will be lambda 1, and lambda 2, here we have taken lambda max of paracetamol as lambda 2. So you have to measure the paracetamol solution and mefenamic acid solution at both the wavelengths. Here we have taken paracetamol as a X and mefenamic acid as a Y. So measure the absorbance A of paracetamol X at lambda 1 to get AX1, and measure the absorbance of mefenamic acid Y at lambda 1 to get AY1. Similarly, measure the absorbance of A, that is A of mefenamic acid Y at lambda 2 to get AY2, and measure the absorbance of paracetamol X at lambda 2 to get AX2. Lambda 1 is our isoabsorptive point and lambda 2 is a lambda max of paracetamol. So at both the wavelength you have to measure both the components. Now coming to mefenamic acid sample solution, you have to take absorbance of the sample at lambda 1, that is isoabsorptive point, and lambda 2, that is at lambda max of paracetamol lambda 2. Now coming to calculation, here the isoabsorptive point or isobastic point is 233 for these components, and lambda 2 is, we have taken paracetamol, lambda max of paracetamol, that is 255, near 257. So 255 the reading is, so that is our lambda 2. So paracetamol X we have measured 10 ppm at both the wavelength to get AX1 and AX2. And for mefenamic acid we measured 10 ppm mefenamic acid standard solution to get AY1 and AY2 at both the wavelength, and you have to calculate absorptivity. How will you calculate absorptivity? How these absorptivities are calculated? So for absorptivity, the equation is A is equal to ABC, where A is absorbance, A is absorptivity small a, B is a path length, C is the concentration in gram per 100 ml. This is very important. So for I have given the calculation for AX1. AX1 is equal to A upon BC. A is equal to ABC, so small a will be A by BC. So absorbance is 0.660. Path length is 1. This is very important. C is 0.001 because we have to convert ppm into gram per 100 ml. So 10 ppm is 0.001 gram per 100 ml. So absorptivity here AX1 will be 660. And similarly I have calculated the absorptivity of both the components at both the wavelengths. Now for sample, you have to just find out absorbance of sample at both the wavelength. At lambda 1 it will be A1 and lambda 2 it will be A2. Now if you place the values here in this equation for Cx and Cy, you will get the concentration X and Y. But the concentration you will get when you solve the equation, you will get in gram per 100 ml because while calculation of absorptivity, we have considered concentration in gram per 100 ml. So again you have to calculate or convert your concentration into gram from gram per 100 ml to ppm. So suppose the value is 4.78 ppm for Cx and 6.769 for Cy. X is our paracetamol, Y is our mefenamic acid. Now we know that from the equation from this slide that our theoretical value for paracetamol was 6.5 and mefenamic acid was 10 ppm. So 6.5 ppm paracetamol is 100%. So theoretically this is our theoretical value. So that is our 100%. So 4.78 which we got practically is how much percent? So 74.86%. Similarly, you can calculate for mefenamic acid. 10 ppm is 100%. So 6.769 is how much percent? So that comes around 75.26%. So result you can mention that the given tablet sample contains 74.86% of 74.86% of paracetamol and 75.26% of mefenamic acid. So this is all about estimation of paracetamol and mefenamic acid using absorption ratio method. Thank you all for patiently listening. Have good day.